Hi guys, in this video I'm going to show you how to create an upgradable NFT smart contract. This particular video builds on the concept that we have learned on our last video where we create an upgradable smart contract from scratch. In this video, however, we are going to apply that concepts and technicalities to a real use case scenario, which is we are going to create an upgradable NFT smart contract. For this one, we are going to use some tools and also import some smart contracts that will abstract away most of those technicalities regarding upgradable smart contracts. So if you're ready, then let's proceed and write our smart contract. So the first thing we need to do is in our desktop, create a folder and name your folder upgradeable-nft and open that particular folder, and then inside of that folder create two new folders. First folder, we'll name it front end. The second folder, we will name it as hard hat. So the front end folder, it will contain our front end codes like the index HTML and the scripts. The hard hat folder, on the other hand, will contain our smart contract codes. This time we'll be using a tool called hard hat, and I will show you the steps on how to set up hard hat in your local machine. After that, we can now close this folder, and let's open this particular folder in our VS Code. I will open my VS Code right here and go to File and click Open Folder, and then go to Desktop where that particular folder is saved, and then choose Upgradable NFT, and then click Select Folder, and it will open the folder for you, and just click this one. Now inside of that folder, it still contains the front end and the hard hat folder. After opening the folder in VS Code, what we need to do next is open the terminal. You can go here, terminal, and then select new terminal, and it will open the new terminal for us. In the terminal, just type cd hard hat. CD stands for change directory. So basically what it does is it changes our directory from our current folder, which is upgradable-nft, to the hard hat folder inside of it. Click enter, and now we are basically inside of the hard hat folder now. For the next step, we need to install a particular tool called Node.js. So here's the Node.js website. I suggest that you download or install Node.js based on your operating system right here. After installing Node.js, what we can do in the command line is to check first if Node is properly installed. So what we can do is type node --version, press enter, and it should return to you the version or the current version of Node installed in your system. Now, if we have that, then it means that the Node.js is installed properly in your machine, and we can now proceed to the next step. The next step that we need to do is to initialize Node or npm in our hard hat folder, and to do that, we just type npm init --y and press enter. And if we open our hard hat folder right here, you will see that it generates a package.json file. So the next step that we are going to do is to install hard hat. And to do that, we just type npm install --D, which means that this particular install will be saved to the dev dependency. After that, we specify which package or module we want to install. And in this case, we want to install hard hat. And another tool that we need, which is Atomic Foundation /hard hat-toolbox. So hard hat, it is the main tool that we need. This Nomic Foundation hard hat toolbox package, it just provides us additional tools in partner with the hard hat module that we are going to install. So press enter, and it will install for us. After installing hard hat, we need to install two more additional packages for this video tutorial. So again, let's type npm install --D, and I will paste the two packages that we need to install. The first one is the OpenZeppelin contracts -upgradable and the OpenZeppelin hard hat upgrades. So this one, the contracts -upgradable, it provides us the smart contracts that we will import later on that gives us the utility to make our smart contract upgradable. The other one, the OpenZeppelin hard hat -upgrades, it provides us another utility, but this time in the hard hat console, to have the functionality to deploy a proxy and upgrade a proxy. So now let's install. So now the installation is finished, and we can now proceed to writing our smart contract. So before we proceed, we first need to initialize hardhat inside of our hardhat folder right here. And in order to do that, we just need to type npx hardhat in the terminal right here and press enter. And it will give you some options to create a project in JavaScript, TypeScript, or an empty hardhat config.js. But in this case, we will create a project based on JavaScript. So select that and just press enter on the hardhat project root. And it will ask you, do you want to add a git ignore? Then just choose yes. So after that, hardhat is now initialized. And as you noticed here, it creates us files and folders that we can use later on writing our smart contract. Now we are done setting up our development environment using hardhat. So now let's proceed to the next step of our video tutorial. So for this session, we won't be writing our smart contract code from scratch. Instead, we are going to make a tool called the Upgradeable Smart Wizard. So in this particular tool, or in this particular website, we can generate a smart contract code for ERC20, ERC721, ERC 1155, and so on and so forth. So these smart contracts will be provided by Upgradeable, and they will automatically provide the full force to their own smart contract. Now, that implement the particular ERC standard that we are going to use. So in this case, since we are doing an NFT smart contract, so we are going to go with ERC 721. And for the settings, we need to the name. We can leave it as my token and the symbol MTK. The base URI, you can just keep it empty. And the features that we need are this one, linkable, and the URI storage right here. And as you can see, it automatically generates a code for us. So in the upgradability section, we just need to select the UNITS type of upgradability. And it will revise the code based on the choice that we click right here. So now this is the entire code for our smart contract. And what we will do is copy it by clicking this copy to clipboard button. And then let's return to GS Code. And inside of the hardhat folder, there is a contract folder right here. And inside of that, there is this file called block.solve. And this is just an example file that we can delete. Well, I'll go delete it. And inside of the contract folder, I'm going to right click and create a new file. And I'm going to name this file my token.solve. And I will paste the entire code that we copied from Upgradeable Wizard right here. So going back to our my token smart contract code right here, basically what we are going to do next is to add some modifications to this particular code or smart contract. And in this case, we are going to add a count variable right here. So it's UN256. It is a public variable and the name is count, and it will be initialized to 0. And the next modification that we're going to do is in the SafeMint function, which is right here. So instead of passing the UN256 token ID, we are just going to delete this parameter, and instead we are going to initialize that inside of the function block token ID right here. It's a UN256 token ID, which will take the value of the current count, and it should be incremented before it is assigned to the value of token ID right here. So now let's explain what this code does. So the first two lines, we just identify the license, which is the MIT license. The second line, we designate which version of Solidity we're going to use, and in this case, we are going to use version 0.8.9. And the next few lines right here, we are importing the upgradable contracts from OpenZeppelin. And next is we are writing our smart contract right here. And in this case, the contract name is my token, and we are extending or inheriting from the smart contracts that we have imported right here. So basically, those are initialized ERC721 upgradable, URI storage upgradable, ownable upgradable, and UUPS upgradable. So these are all the smart contracts that we need to inherit. So if you are going to, so inside of this smart contract, we initialize a variable of count. And next is we have a constructor, and inside is we have this function called disable initializers. And this function came from one of these imports right here that we extended or inherited. The next is we have this function initialize, and this function will act as a constructor every time we upgrade our proxy. So once we upgrade our proxy, this particular function will be called. Inside of this function, we just initialize the name and the symbol, and then we update the URI storage, and we just initialize the ownable and the UUPS upgradable smart contracts. The next function is the function SafeMint, and in here we are just passing two parameters, which are the address 2 and the string URI. And this particular function is public, so that anyone can use this particular function, and it is limited to only owner. So only the owner can use this particular function right here. And inside of this function, we have this code right here. The first one is first we increment count. So starting from 0, we increment it by 1. And then we assign it to the variable token ID, which is a uint256 type. And then we call the SafeMint function from the URIs from the ERC721 upgradable storage smart contract that we inherited. And we pass two arguments, the to address and the token ID right here. And then the next function we are going to call is the set token URI, which we pass basically the token ID and the URI or the URI of the NFT that we are going to mint. The next function is this one. It's underscore authorize upgrade. And in this function, we pass a parameter called new implementation, which has the type of address. And this one is internal. And this one is called only by the owner. And it is basically overridden. But inside of this function, we don't have any particular code that we are running. So this particular code, it basically checks if a certain user is authorized to upgrade this particular implementation contract. But in this case, we are not going to check for that user, or we are not going to check if a user is authorized to upgrade. So basically, it's just the owner who is going to upgrade. And then these other three functions, these are override functions that are generated by the Open Zeppelin contract wizard right here. So it just overrides the function burn, and it overrides also the function token URI, and it returns this token URI function, and it also overrides the support interface function right here. So after writing the MyToken smart contract, we can now proceed with the next step. And in this step, what we need to do is open our terminal again and go again to the hard hat directory. So cd hard hat. And inside of this directory, we need to install a package called .env. So npm install .env. Press enter. So after the installation, we can now close this terminal. And what we need to do now is in the hard hat folder, we can right click and create a new file and name that file .env. So inside of this file, we need to create two variables, rpc underscore URL and the private right here. So for the rpc URL, we are going to get that particular rpc URL using the website called chainlist.org. So now that we are here in chainlist.org, what we need to do is search for the network where we are going to deploy our smart contract. And in this case, we are going to deploy in the Mumbai network. And make sure to check this checkmark to include testnets. And it should show you the Mumbai test network. And click this arrow button down here, and it will, you can see here the RPC server address. and we can just pick one. So I'm going to pick this one, and I'll copy it, and then go back to my VS Code and assign that value to the RPC URL variable right here. So for the private key, we can basically get that private key in our MetaMask wallet. So I'll show you the steps on how to do it. So go back to your browser and click MetaMask. Open it up and just click this account 1 or whatever the account name for you. And beside that, you can see this vertical ellipsis. Click that and click this account details section and click this show private key. It will ask you for your password, and just be very careful with this warning. So never disclose your private key to anyone, since if they gain access to this private key, then they can basically gain access to your account. So back in my browser, I have copied my private key, but I won't show you my private key since I'm using this account privately. And what we need to do once we copied that particular private key is assign it to this private key environment variable. We can just paste here. We can just paste here our private key. So now I am done with the setting up of the .environment or .env file. What we can do now after that is go to this file called hardhatconfig.js, and we will be setting up this file. So what we need to do is add a require statement here, and we are going to import the Open Zeppelin hardhat upgrades right here. And aside from that, we are also going to import or require the .env package that we have downloaded earlier, and it is followed by the .config command right here. So inside of this module.exports, we are going to add some new lines here. So we will add the network, and it will be an object, and inside of that network, we name the particular network we are going to use, which in this case is the mobile network. And it is also a object, and inside of that we have the URL, which we're going to assign to process.env.rpc_URL, and the accounts key right here. And the accounts key is an array, and inside of that array we have our process.env.private key. So remember that this RPC URL and private key variable are defined inside of our .env file right here. So that's why we need to use this particular prefix process.env in order to access those files from the .env file right here. And also we need the package .env in order for us to do this particular syntax. Otherwise, it will return as an error or a null value. So this is what our hardhatconfig.js contains right here. And now we are basically finished setting up this particular file. And we can now proceed to the next step. So the next thing we are going to do is create an index.html file in our front end folder right here. So inside of this index.html file, we are going to paste this particular HTML code right here. Basically, it will render a simple web page where we can mint an NFT, and we can see how many NFTs are minted via a count variable. Scrolling down in this index.html, we can see this particular line, var address and var ABI. So this is where we will put our address and ABI later when we have deployed our smart contract. So we can open our terminal again by pressing Ctrl J. So here is our terminal, and what we need to do next is compile our smart contract. So in order to do that, we need to type the command npx hardhat compile right here, and it will compile our Solidity file. First is we need to get the ABI, and in order to get the ABI, we go to the artifacts folder that was generated after we compile our smart contract, and then go to contracts and go to mytoken.json. And inside of here, you will see the key ABI followed by an array of values. So that is the ABI that we need to copy. So we copy it, all of it. And in the index.html, we just delete this empty array and paste that particular ABI that we copied from the artifact folder. So next, we are going to deploy this particular smart contracts via a proxy. Now we are going to deploy our smart contract via the console on our PS Code. So to do that, we need to type the command npx hardhat console and then pass in the -- network flag. And the network that we want to connect to is the mobile network. Once we have that typed, then we can press enter. And let's wait for the hardhat console to get initialized. Now we have initialized our hardhat console. And what we can do now is to get the contract factory of our MyToken smart contract that's sold right here. So to do that, in the console, we type the MyToken. MyToken. We type MyToken and await users that get contract factory, and we pass in the smart contract name right. And then we press enter, and it now basically generated the contract factory based on the MyToken smart contract, and it assigned it to the variable MyToken right here. So now we are going to deploy this particular smart contract along with the proxy smart contract. And for us to do that, we need to type in the command await upgrade.deploy proxy, and here we pass the MyToken contract factory, which is the MyToken variable that we have assigned earlier. And what we can do is assign this to a particular variable, and I will call that proxy contract. And then press enter, and let's wait for this particular proxy contract and implementation contract to be deployed. Once we have successfully deployed the proxy contract and the implementation contract, we can now get the smart contract address of the proxy contract by typing in the console the command proxy contract.target, and it will return to us the smart contract address of this particular smart contract, or the particular proxy smart contract. What we need to do is copy this particular smart contract address and go to our index.html, and in this var address, this is where we put the proxy smart contract address right here. And basically, after this step, we are now done with the setup of our upgradable NFT smart contract, and we can now test it. So what we need to do in order to check for it is to launch this particular index.html. And in order for us to do that, we need to install a particular extension called live server right here, live server. So if you have that installed, then good. If not, then what you can do is just search here in the marketplace live server, and then install this particular plugin by weekday. So once you have installed that particular plugin, the live server plugin, what we can do is the index.html right here in the Explorer, right click, and then click this open with live server, and it will open a local host for us right here. So what we can do is go to our browser and go to that particular address, localhost 5500. So if you're redirected to this type of page, what you can do is just go to the front end, and yeah, here it will be, the website will be rendered for you. So here in the website that we have created, make sure to check your MetaMask first and ensure that you are with the owner account, that the current owner account should be shown here in your MetaMask wallet. The owner account is the account that deployed the particular smart contract. And in this case, this is my account 1 wallet account. So after that, just click this connect button, and it will connect our wallet to this particular website right here. So what I can do now in this particular web page is to mint a particular NFT. And in order for me to mint an NFT, I need to paste the token URI right here. And I already have the prepared token URI, which is this URI. So I already uploaded this metadata to the IPFS along with the image. So yeah, I'm going to use this particular token URI. So feel free to generate your own token URI by uploading an image and metadata in the IPFS. Otherwise, you can use this particular CID to mint an NFT using my own IPFS token URI. So what I'm going to do is I will copy this, and then in the website right here, I will paste that particular token URI right here, and then I will click mint. And MetaMask should pop up saying that I am interacting currently with this particular smart contract, and the function that I am trying to call is the safe mint function. Scroll down. After the gas estimates, just click confirm. And let's wait for the transaction to finish. So once the transaction is finished, please go to this testnet's OpenSea.io website. So this is the testnet site of OpenSea, and make sure to connect your account here. And in order for us to view that particular NFT that we have recently minted, we can just check the profile of this particular address that we currently logged in. And you can see here this particular NFT that I have minted is this one. So let's check the detail. By opening it, you can see the name, the image right here, the details of this particular NFT, and along with the traits. And scrolling down, you can see here that I have recently minted it 1 minute ago. So this is the recently minted NFT that I have right here. So going back to this website right here that we have, what I will do now is change the wallet address. So from account 1, I will change to account 2. So now I am in a different wallet address, and basically this wallet address is not the owner of this particular smart contract that this website is interacting with. So what I'm going to do is first refresh the website, and then I will connect my wallet with this particular website, and I will again paste that particular token URI right here, and I will click mint. And MetaMask will pop up, and along here is we can see this warning message or error message that says that there might be an error in the contract and this transaction may fail, which is it might not fail because this will definitely fail. So why we have this error is because when we check our mytoken.sol, the safe mint function that we are trying to call is tagged as only owner, which means that the owner of this mytoken.sol or whoever deployed this particular contract will be the only one who is allowed to call this function safe mint. So that is the reason why only the previous account, the account 1, can call this particular function and not account 2. So now the next step that we're going to do is upgrade this mytoken smart contract. So the part that I'm going to upgrade is this function safe mint. So in the current implementation, only the owner can use this particular function. And what I'm going to do is remove this only owner modifier in the safe mint function in the second version of this mytoken smart contract. So to do that, we can just copy this particular smart contract and then paste it back in the contracts folder, and it will give us a copy of the mytoken.sol. Rename this copy to mytoken2.sol, and inside of that file, rename the contract to mytoken2, like that one. In the safe mint function, what we need to do is just delete this only owner modifier right here. So now what it basically does is we are enabling anyone or any particular user to call this safe mint function and mint their own NFT for their own use. So now we are done with writing the second version of our mytoken smart contract. And what we can do now is open the console and then run the iRhat console. So in order for us to do that, we can move first or change directory first to the iRhat directory, and then run npx iRhat console, passing in the network flag and the network that we want to connect to. And press enter. The first step, now that we are inside of the iRhat console, the first step that we need to do is first create the token factory for the second version of the mytoken smart contract. So in order for us to do that, we need to type this command await ethers that get contract factory and passing in the name of the second version of the my token smart contract, which is my token. Press enter, and now it generated the contract factory for this particular smart contract. Now we can upgrade our proxy to this second implementation of the my token smart contract. So in order for us to do that, we need to type this following commands: await upgrades that upgrade proxy. And this upgrade proxy takes in two arguments. The first argument is the smart contract address of the proxy. And the second argument is the contract factory of the second version of the my token smart contract. And once we're done, we can press enter and wait for the transaction to finish. So now that the transaction is finished, it means that the implementation contract is now upgraded to the second version of the my token.sol. And to give a review of what we changed in the my token what we changed in the my token2.sol is that we make the statement function callable or executable by anyone by removing the only owner modifier that was included here in the first version of this smart contract. So going to our website right here, let's first check MetaMask. And currently I'm in account 1, or the owner of this particular smart contract address. So let's check if this particular account can still mint NFTs. So connect and then paste here the token URI. This time I'm going to mint the second image I have in this CID. Then I will press the mint button and MetaMask will pop up saying that I am interacting with this particular smart contract, and the function I'm trying to execute is the safe mint function. And as you can see, the gas prices was estimated, so we can click confirm and wait for the transaction to finish and mint our NFT. So the transaction is finished, and we can check our profile in OpenSea, and we can see here the image that we have recently minted. So let's open it, and you can see here that it is minted just 40 seconds ago. So this is the NFT that we have recently minted. So this is minted by the first account, or the owner account for this smart contract that we are currently interacting. So now we are going to try and call the mint function in another account which is not the owner of the smart contract. So I'm going to open MetaMask and switch to a different account, this account 2 right here. And this account 2 is not the owner of this smart contract. And I'll refresh this page first, and then I will connect and then mint the token URI. And again, I'm going to change it to the second image I have in this CID. Now I'm going to click mint. And if you remember earlier in the first version of the smart contract, we received an error saying that the gas price cannot be estimated and there might be an error running the code. But this time, in account 2, and we are calling the safe mint function, we are not receiving that error anymore, which means that we can now confirm this transaction. And we'll wait for a while for the transaction to finish. The transaction is now finished, and we can check the profile of our account 2 in OpenSea. And you can see here that I have minted the NFT image. I'm going to open it, and you can see right here that it is minted 34 seconds ago. So this means that this is the recently minted NFT that we have right here. And as you noticed, the account 2 can now mint NFTs, which means that our contract was upgraded from the first version, where only the owner can call the safe mint function, to this new version of the implementation contract, where anyone can mint their own NFT. And you will also notice the count value right here, and this counts how many times we minted an NFT. And currently the value is 3. And since we upgraded from a previous version to the new version of the my token smart contract, and still the count variable, or the count state variable, still retain its value since that particular state variable is stored inside of the proxy smart contract. So basically, that is how you implement an upgradable NFT smart contract. With the knowledge you have gained here in this video tutorial, I hope that you can put it to good use and then create your own upgradable NFT smart contract. So this is the end of our session, and thank you for tuning in, and I hope to see you again on our next video.